lecture, we are going to discuss the solution of an important problem, very important problem of three-dimensional geometry. Basically, this is from the chapter plane and straight line. Okay, and the problem is, let L be the line of intersection of the planes x plus y, this is equal to 0, and y plus z, this is equal to 0. Two planes are given and the equation are this and this. Okay, and this problem also have two parts, and the first part is write the vector equation of L. Okay, where L is the line of intersection of the given two planes, and that is we have to find the value ABC and PQR such that the line can be written in the form ABC plus lambda into PQR, where lambda is a real number. Okay, we first solve the first part, then we go to the second part. Here the planes are given by, for the answer of first part, planes are given by x plus y, this is equal to 0, and y plus z, this is equal to 0. Okay, and we very simply find this is minus x, this is equal to y, and from here we get y, this is equal to minus z. Okay, so we can write this is minus x, this is y, this is minus z, and this can be written as x, this is by minus 1, and y by 1, and z by minus 1. Or we can write it x by 1, this is y by minus 1, and this is z by 1. Okay, we write in this form because this is the symmetrical form of straight line. Okay, so if we try to write the equation of this line in this form, so we take here a constant or real constant which is lambda. Okay, and we get x, this is equal to lambda into 1, y, this is equal to lambda into minus 1, and z, this is equal to lambda into 1. Okay, so we write the equation of this line in the form as 0, 0, 0 plus lambda into 1 minus 1, 1. Because this straight line is passes through 0, if we write here in the form x minus 0, y minus 0, z minus 0. Okay, so it is 0 plus lambda into 1, it is also 0 plus lambda into minus 1, it is 0 plus lambda into this. Okay, so comparing this relation with the given relation, we can write that A, B, C, this is 0, 0, 0, and P, Q, R, this is also 1 minus 1, 1. Okay, we very simply solve the first portion. Right, now we go to the second part. In the second part, it is said that find the equation of the plane obtained by rotating x plus y equal to 0 about L by 45 degree angle. Okay, and now we try to solve the second part. This is the part B. Here we have to rotate this plane. Okay, about the angle theta. So here we write the plane is x plus y, this is equal to 0, and angle theta, this is equal to 45 degree, and above the line is L, and which is given by x by 1, y by minus 1, and z by 1. Okay, now if we let new plane be, this is ax plus by plus cz, this is equal to 0. We write the plane in the form ax plus by plus cz, this is 0 because the plane must be passes through the origin, because the line containing the plane, or we say this plane must contains the line, so this plane must passes through the origin because line passes through the origin, so there is no constant term. Okay, for this reason we let this, and for this plane obviously this is the normal, A, B, C is normal. If we take this is a dash, b dash, c dash, and we take here a dash, b dash, c dash, because ABC already used here. Okay. Now this is the plane, and the normal of the plane is a dash, b dash, c dash. And since the normal of the line, okay, direction cosine or normal of the line is 1 minus 1 1, and since this plane contains the line, so we know that the normal of the plane and the normal of the line must be perpendicular, because normal of the plane is along the perpendicular direction to the normal, but normal of the line is along the straight line. So this normal vector and this normal vector must be perpendicular to each other. So using the condition of perpendicular vector, this and this, we get the relation as a dash minus b dash plus c dash, this is equal to 0. This is relation number 1. Also, since this plane is rotated through an angle 45 degree, and we get the new plane as this, so the normal of this plane is 1 1 0, and we say that the angle between this normal and this normal must be 45 degree. So we get another formula. This is cos 45 degree. This is given by 1 1 0 dot, this is dot product a dash b dash c dash by root 1 square plus 1 square plus 0 square. This is 1 square plus 1 square plus 0 square into root a dash square plus b dash square plus c dash square. Okay, and getting the result as this is a dash plus b dash by root 2 into root a dash square plus b dash square plus c dash square, and from the left side we get 1 by root 2, and root 2 cancel out. From this relation we get a dash square plus b dash square plus c dash square. This is equal to a dash plus b dash whole square by squaring both sides, and getting the relation as c dash square. This is equal to 2 a dash b dash. Right? Here we get two relation 1 and 2 containing 3 variables. So we must have to let one variable as a known number. Okay, let, for simplicity, here we let a dash, this is equal to 1. Okay, and if a dash this is equal to 1, then we get b dash, this is c dash plus 1. Okay, from this relation, and we put the value of b dash here, and a dash also 1 we put here. We get c dash square, this is 2 into 1 into b dash means c dash plus 1, and getting the relation as c dash square minus 2 c dash minus 2, this is equal to 0, and this is a quadratic equation of c dash. And from here we get two value of c dash. C dash is given by 2 plus minus root under b square means 4 minus 4 is c. This is given by 4 into 2, 4ac by 2a. Okay, so we get 1 plus minus, this is root 3, and this value is c dash, this is 1 plus root 3 or 1 minus root 3, and if we put here this value of c dash, then we get b dash, this is 1 plus minus root 3 plus 1. So we get 2 plus minus root 3. So we get two pair of values of a dash, b dash, c dash. These are given by 1, and the value of b dash, this is 2 plus minus root 3, and the value of c dash is given by 1 plus minus root 3. So by putting the value of a dash, b dash, c dash in the equation of the plane, we get the required equation, as the first equation is given by x and b is taken 2 plus root 3 into y, plus then c is given by 1 plus root 3 into z, this is equal to 0, and this may be one answer, and other answer may be x plus 2 minus root 3 into y plus 1 minus root 3 into z, this is equal to 0. Okay, any one can be done for this answer. or right for this answer. Okay, this is the second answer of the problem. Very, very interesting type of problem from plane and straight line. Thank you for watching.